mean, the downside
companies
is
would have already invested in moving away from it if it was so expensive. Server resources are actually the same.
well, you also have the trade-off that you have to do HTTP requests back and forth if you do.
Did you know they have
I mean, that's fine too. Like, there's.
I'm just wondering if there's a money trade-off in the terms of the. I've always
all
wondered
all
that.
of the architectures work.
What?
It's just, I said, like, all the various architectures will work.
Yeah.
It's just a matter
I
of
see.
what
So
you're
which are
trying to
trade-offs?
optimize for.
like initiating one repo
Yeah.
and then another that's
From a business perspective.
Sure, yeah,
Gotcha,
I'm
that
just
makes
asking
sense.
about the money, to be honest.
Yeah.
And on client side,
I don't.
with like single page apps, older Android devices, you better be really optimized or else they're just gonna choke. You're gonna pay that huge parse cost.
Yeah.
Oh, well, yeah, but that's one of those things, it's like, oh, well, my users are using Internet Explorer 2, well, stop doing that. You know what I mean?
You can't
Get better
control that.
users.
You gotta find the money. That's where the money's gonna be.
Oh, man. Alright. So you better sell me on this, man, because I don't believe in testing.
This might not be the right talk for you then.
I know.
Gotta like testing.
Tell me why I'm wrong.
I still don't understand how to get to the actual live stream on this thing. Am I dense? Am I confused?
Nope, you're not. It's still baffling.
It feels like it should be easier to figure out.
Are we on the Facebook one tonight, or
Huh?
are we on the Facebook?
Oh, I don't know. That's. What's their YouTube? Is it Austin Tech Live on YouTube? Oh. Well, I was on the wrong thing, but we linked to the wrong one. So, update that. Where is the edit? Where's the edit? Lord. Isn't there normally an edit link in this? Can I not edit it because it's started or something?
Should be under organizer tools.
That's what I thought too.
Maybe because it's already started.
That's what I was wondering, yeah.
Yeah. I just posted it in the comments on. I'll put it up in Slack too.
Okay. There we are. Hello. All right, we'll wait a few more minutes just in case people are fighting the weather.
I'm not using the shirt. Right, exactly.
Reserved area.
Not bad. So you do my fault, so.
Yeah, the rain is crazy out there.
Yeah.
Hi, Brian.
Yeah, it doesn't seem to want to make up its mind whether it's going to pour or drizzle. So.
Oh, no, it's good to be living downtown.
Yeah.
Robert was coming from Cedar Park. He said he left his house at like 5, and he got here right when I did. 6:15. He said when he got to the toll lane on your pack, he said he bring up like 8 or
So I went to the Homeway in the Domain, and it was the Homeway downtown. And so I was out in the Domain, I was like, I make it. Got in the toll lane, 5 minutes, was downtown, Village Park. I was like, if you catch it, it's perfect. And everybody's going opposite direction.
So I don't usually have to battle Mopac traffic during rush hour, but the other day we had to come out and stuff. And lo and behold, got rear-ended on Mopac. Yeah, I did. Luckily it was just like it didn't damage the car or anything, but felt the whiplash for a day or two. And Tina was in the car, which is always a little challenging for her. So it just amazes me how little attention people actually pay, when they're on the road. And that's that would be a benefit right there of taking this lesson. Yeah, is this a Cloudflare thing? I'll do that on my phone, that way I don't have to like grease up your phone.
That's fine. I wanna post it from the Edge account, so I just wanna.
Oh, okay. All right, I'll do that.
Actually, last time you posted it to Meetup,
Mhm.
I was able to just download it and post it, so that works too.
Okay. All right, I'll do that.
So I guess we'll go ahead and get started. We're expecting a few more people, but with the rain, you never know. People decide to change their plans or whatnot, but we might still have people filtering in later. So, welcome to Bleeding Edge Web. You guys ready to get started?
I think Brian wants to get started with the meetup.
Better late than never. Yeah, so welcome to Bleeding Edge Web. Normally, we start off with a little news from the Bleeding Edge, which I'm about to do, and then our main talk of the night, as you guys probably know, is testing big with JavaScript with Robert here. So he'll be up in just a little bit. First off, just a couple of announcements. Why is that? So some sponsorship. Thanks to Capital Factory, as always, for being our venue sponsor. We really appreciate Capital Factory doing that. And Cloudflare, again, this month is our food and drink sponsor. So just a quick shout out to Cloudflare. If you haven't checked them out, and if you do any web or app hosting, they're really super useful for a lot of reasons. I think they host, 10% of internet traffic as of when this slide was made, which was a little while back. They basically sit in front of your site and provide a lot of services like proxying, denial of service mitigation, caching, lots of useful things. This is kind of an example of what that looks like. So another cool thing they do is they have an app platform. So they have third-party apps that you can actually plug into your website server-side to do things like more advanced filtering or custom, stuff that you might want to do at that level. So pretty cool platform. And the great thing about it is they actually have a very good free level. So it's really simple to get started for no risk. Check them out. They're also in Austin. They have a developer shop here in Austin. Yeah.
Sorry, I just want to mention they also have an IPFS gateway that they just came out with like this week, which is really, really cool. You should check out. That's it.
So thank you to Cloudflare. And then a little bit of housekeeping. So speakers and sponsors are always welcome and wanted. So if you know someone or if your company might be interested, either talk to us after the meetup or go to edgeatx.org where all the links are. Also, parking has changed again. So they went from from validating forever to not validating for a little while to now they're validating parking again. So if you parked here in the building, make sure you stop by the desk and grab a little parking validation card before you leave. Don't forget. One of the rule changes, though, is you have to be out of the garage by 10, or they actually charge you for the full day anyway, so just keep that in mind. After the meetup ends, if we have time here before 9, you can hang out. After 9, we usually go downstairs and hang out for a little bit if anyone's interested, and continue the discussion. There's a little hotel bar right downstairs. And then, does anyone have any announcements as far as like your company hiring, or are you looking for a job, anything like that? No announcements. Cool. All right, well, let's get started. Oh, great. So I updated Chrome because they updated. They must have changed their option again for this.
View, always show toolbar. Second one, maybe.
Ah, there we go. No.
Or not.
Little bug. So that was a little preview of Chrome, which just updated, which we're going to talk about in a minute. So apparently that little option was a little buggy. Good to know. All right, news from the bleeding edge. Browser update, as I just alluded to. So spoiler alert, Chrome updated. Also, Firefox had a little bit of an update. They actually updated on the exact same day, which was kind of interesting. So Chrome 69 was released on September 5th. One of the first things you'll probably notice is they did a UI refresh. You know, if you've been following Google at all for the past couple of years, they are making a big push to sort of material UI everything. This isn't, the UI of Chrome itself isn't particularly material UI, but they sort of simplified it and made it really, I think, generic on purpose to kind of highlight the material UI application Chrome when you load material UI into the browser. I think the jury's still out, according to sort of reactions I saw online. A lot of people don't like it, some people do. We'll see, but pretty sure we're stuck with it, so might as well get to like it if you don't. A few interesting features that came out with Chrome 69. So CSS scroll snap is a feature that I don't know if any of the other browsers have implemented it, but it's actually pretty cool. It provides you a really simple CSS-based way of providing like carousel transitions that actually snap to position. So instead of having to write fancy code to kind of position your, whatever you're scrolling, images or carousel pages, you can actually just snap positions using CSS properties, which is pretty useful. Now that we have iPhone 10 and all of the predictable copies of iPhone 10 for the past year, the browsers on mobile have by default started to create margins so that the little notch in an iPhone, for example, doesn't overlay content accidentally. So they actually create margins and artificially kind of squeeze your content. So if you don't like that, if you would rather handle that explicitly, you can actually override that with this property called safe area inset. And then if you use this viewport fit, which is a kind of existing tag that you can do, then you can actually control that. So it's a good thing to know about if you're interested in supporting mobile browsers on newer phones. And then this one is a little more computer science-y, but there's this API called the WebLogs API. And it's kind of important on certain specific cases. So if you're doing expensive like asynchronous calls, like a web service call or a database transaction or something like that, but you want to make absolutely sure that nothing else in your local code executes and does the same kind of thing. The concept of locking has been around in computer science forever, but now you can actually do it via a browser API. So you can actually kind of lock a resource, wait for something to finish, and then sort of unlock it in JavaScript. So again, most people won't necessarily need that, but it's good to kind of know about in the event that you do. And then a few minor features. I won't go over all of these. I will mention the array methods, only because we actually talked about this a few months ago when there was this big controversy about array.smoosh. So I won't go over that again, but it's actually kind of an interesting thing. If you're interested, you can get the slides and click on that. But the long story short is array.flat is kind of a stupid method name, but they couldn't use .flatten because it would have, for very arcane reasons, broken sites that might still be using MooTools. So very random. If that's interesting to you, you can read about it. But we have array.flat, array.flatMap, which are basically ways to flatten arrays. Firefox also came out. As you can see, they also put array.flat and flatmap in this release. Also a couple of other things, WebAssembly.global, just a way to kind of provide global instance variables if you're using WebAssembly. Import.meta. Meta is kind of useful for certain cases, so you can actually access meta information about the file that you're in actually executing in JavaScript. So the example is you can actually get the URL of the browser in the context of your JavaScript without having to do like, window.location or whatever. So this is the actual file system file, as you can see there, which is different. And they actually had a lot of minor updates. It was kind of a typical Firefox release. Lots of DOM, CSS, and DevTools stuff. Nothing super major, so if you're interested, you can check out the release notes, but there wasn't a lot of other noteworthy stuff to talk about. And then there was actually a new browser announced. Is anyone aware of that? No one?
Oh, it's the distributed browser, right?
It's Firefox Reality 1.0. So it's actually a ground up, designed for VR browser. They call it mixed reality, I guess, because the browser content itself is, I don't know, reality, I guess, as opposed to virtual reality around it. So you're like really on the web inside of VR. I guess that's the analogy. But kind of interesting. So I'm not actually personally a big VR guy, but I know that the various platforms kind of have their own, basic embedded browsers. But the idea of having Firefox, the ability to run Firefox within VR is kind of cool. Firefox obviously knows a lot about building good browsers. It's open source. They have voice search, private browsing built in, and it's currently available for these common platforms. Now, I will admit, I went and looked at some of the reviews on those platforms, and the jury is definitely out on this right now. It's a 1.0 browser. A lot of people aren't super impressed, but Mozilla knows how to build browsers, so if you do VR, I would definitely keep an eye on this one. And by the way, we're not going to add that to our list that we talk about every month, so that was just a little one-off, but I thought it was interesting news. So this section is languages, frameworks, and libraries, so just sort of interesting news or new frameworks that might have come out. Has anyone ever used Johnny 5? So it's actually a JavaScript library for doing kind of robotics and Arduino, like physical programming. It's pretty cool, and it's actually been around for a long time, like 5 or 6 years, but it's just now hitting 1.0. So you can, like I said, control anything from Arduino to Xbox. Here's a little example of code that you could connect to an Arduino board and light up an LED, for example. That's how simple it is. So, if you're ever interested in kind of playing around with stuff like that, it's at 1.0 now, so it might be a good time to check it out. Babel, if you do any JavaScript or Node programming, I'm sure you've heard of Babel and probably used it. So Babel 7.0 just came out, and it was a massive release. So it's been in development from 6.0 for about 3 years. It has 4,000 plus commits, and there's a lot in it, so we can't possibly talk about all of it right this second. I listed a few of the highlights there. If you are currently using Babel, you should be aware that this is a breaking change, but the cool thing is they provided an upgrade tool along with it that they claim works very well, so definitely check that out. One thing that I thought was very interesting is this. So if you're familiar with Babel, in the past, they have this concept of presets. So if you follow JavaScript or ECMAScript, I guess, the way it works generally is people make proposals, and then those proposals go through various stages until they finally, either get rejected or become part of the standard. And so you'll have stage 0 through stage 4, and then finally kind of things that end up as standards. In the past, Babel has basically just had simple presets called stage 0, stage 1, stage 2. So if you wanted to play with experimental stuff, you basically had to enable everything within that sort of stage of development. So they've broken that up, and now every single individual TC39 standard proposal that I guess can be supported are supported individually. So you can import very specific things and play with them instead of whole presets. So that's kind of an interesting one. If you're aware of how that works, it's a useful feature. And then the only other thing I'll mention is that they actually support built-in classes now. So you can extend from like array, which is kind of cool. And there's been a patch for that in the GitHub repo for Babel for like 4 years. And so when it finally got accepted into 7.0, there was a big celebration for all the people that care about that. Gatsby, does anyone use Gatsby? A couple of people, cool. So I don't personally use it, but I'm very interested in it, and I've been considering playing around with it. 2.0 might be a good opportunity to do that. So it's basically React-based framework for building either static or dynamic websites or applications. You can connect it to lots of different kinds of web sources, like a database or even like a markdown file or a CMS. And then it's basically a React-based kind of application that uses AJAX calls. The cool thing is you can use static hosting, like you could use Netlify or Next.js. And the 2.0 actually feature-wise didn't have a lot of cool stuff. It was more about like supporting the latest libraries and some performance increases. One thing that I thought was kind of funny was they support, quote, ludicrous mode, hot reloading. So if you're familiar with Tesla, that's a Tesla car reference, ludicrous mode. But supposedly they'll hot reload your code basically as fast as you can type, which is kind of cool. So looks like an interesting framework. If you're interested in that, check it out. Electron 3.0 is a very popular framework for packaging Node and JavaScript applications for running on desktop. So 3.0 just came out. They basically updated, again, all the underlying libraries. I didn't actually see any big features. I saw a lot of features and fixes, but nothing that particularly stood out to me. I don't know, Corey might have something more to say about that. But if you're on Electron, check out 3.0. And then this new thing just came out, Kai. Normally, we don't talk about every little utility library that comes out, but this one was a little noteworthy to me. Number one, it was written by this guy, Sindre Sorhus, or Sorhus. I'm not sure how to pronounce it. But if you know him, he's a very, very well-known open source developer. He's done tons of stuff in the Node world. Very well respected, writes good code. And the purpose of this is to provide a very elegant and simple wrapper around fetch. So it's worth mentioning because fetch, more and more these days, is becoming a very common way to do AJAX calls in the browser. It's the standard. However, it's, there's some quirks with it, with its API. So if you've dealt with that before, this would be a good library to check out. It looks really good. It just came out a few weeks ago, but the API of it is much simpler and much more succinct than fetch. All right, industry headlines. There was one thing that caught my eye. Did anyone hear about this Azure outage? Yeah, so the quote from one of the product managers was it was the longest outage for their customers in their entire 7-year history as a platform. So for about 21 or 22 hours, everything was down, including their actual status page was down. That's bad. I won't go into all the details. The postmortem is actually very interesting if you're kind of into that kind of stuff. But the long story short is there was bad weather in Texas, and that knocked out a big data center. And then from there, there was a cascading series of progressively worse and worse kind of failures of different types of systems that should have backed up. And it was kind of interesting. It was nice for me to see this because at my company, we actually had a little Elasticsearch hiccup a few weeks ago where our search was down for like 30 minutes and we were super stressed out. So then when I saw that every single Azure customer was offline for an entire day, I was like, all right, we could have had it worse. I'm sure whoever was in charge of that was not having a good day.
Couple of days.
Yeah, a couple of days. Okay, so in case you missed it, this is our little bucket of just kind of like little news things that don't really fit in with the other stuff. So you may have seen this before. For the last couple of years, there's been this State of JS survey that usually thousands of developers reply to. And so it's a pretty good survey of kind of our industry and, popular tools, popular libraries, and a lot of other stuff. So you can check out last year's results. You can also take the current survey. So I think it's open for at least a few weeks, and I think they're going to tabulate the results in like late October, early November. So check it out. This would be interesting, and when the results come in, I'm sure we'll talk about it here. So if any of you actually reply to it, you'll have to let me know. And then look who's turning 10. So you may have missed this news, but on September 2nd, Chrome and V8 actually turned 10 years old, which is kind of crazy because like if you're like me, I was around as a developer then, and I remember actually waiting on Chrome. Before it came out, everyone kind of knew Google was working on a browser, and in those days, IE 9 maybe was the hot thing of the time. I don't remember exactly 2008, but our choices were pretty limited back then. So I remember it was pretty exciting when that browser came out. You can actually look at the initial commit of it right there, which is kind of cool. This blog post gives a nice little just write-up of the history, kind of the major milestones over the years. So if you're feeling nostalgic, check that out. And now for something completely different. You were probably thinking, if only I could write basic code for the browser. Well, I have good news for you. You can. I don't actually know why this was from Google. It's actually from Google's open source repo on GitHub. Someone at Google, I guess, used their 20% time to port the basic interpreter to JavaScript. So now we can do cool things like, oh, we can do that, which is,
It's very tiny.
yeah, it just says
GitHub pages are down.
that. I was not expecting that. Okay.
There's another Azure out. Yeah, there must be.
Maybe, do they host on, yeah, they do. They got acquired by Microsoft. Are they already on Azure? Uh-oh. That's bad news. Okay, give me my tabs back. All right, that's on GitHub pages. Let's see if this one is too. Oh my gosh, all right. GitHub's having problems. So you can trust me that that was a cute little demo of this game called Donkey. Is anyone familiar? Has anyone ever written BASIC code? So there's this file that used to ship with BASIC years and years ago called donkey.bas, B-A-S. And supposedly that was written by Bill Gates himself. It was one of the first games ever written in BASIC for DOS, I guess, at least. And it's this silly little card game where you try to avoid hitting a donkey. So if that link was working and cooperating, we could actually play that in the browser. And I could show you the source. It's very ugly, basic source, but this is the gist of it. So if you are a masochist, you can import this library, and with that simple JavaScript wrapper call, you can literally write BASIC and run it in the browser. So there you go. If you write something cool with that, let me know. You can come here and demo it next month. And that's all I got. So I appreciate it. Robert, you want to come on up here? Thanks.
Cool. So, just a quick question. How many people here are connected to the Wi-Fi? Okay. All right. So I have something a little bit later. I'll hopefully have y'all run some tests on your own device. So that's coming up. So I'm here to talk about testing big with Big Test. My name is Robert DeLuca. You can find me at RobDel12 on Twitter, GitHub, whatever. I work for a company called The Frontside. We're a UI consultancy. And at The Frontside, we care about a lot of things, but one of the things that we really care about is testing. I came across this tweet that was written, it was in Kent C. Dodd's talk at Assert.js, if anybody was there or saw it. I saw it, I really liked it because I'm not really a fan of writing unit tests for UI. We'll kind of get into that. But I'm a big fan of writing integration tests, and I like testing as a user. But instead of a integration test, how about a UI test? And what is a UI test? And when I talk about a UI test, I'm talking about rendering the full application in the browser. Not just a component, the whole enchilada, the whole thing. When we run an assertion, we want to re-render the application for each assertion to make sure that it's a fresh application, no leftover state, and we can make sure that that is repeatable, and that we can put the application in that state every single time. Like I said, I want to test the application like it's going to be used. I'm not going to be reaching down to an on-click handler, grab the function that's actually there and invoke that function. I want to know when I click it, it's going to do the right thing. Users are clicking, they're typing, they're scrolling. I want mocked network requests. End-to-end tests are slow, and they require a lot of setup to sanitize your data, and that can be difficult to manage. So for UI tests specifically, I like to have the network requests mocked. So what are the benefits of UI tests? Well, they test the integration of the components together and make sure that that application as a whole works together, not as individual pieces. It tests like a user. You're going to be clicking, you're going to be scrolling, you're going to be dragging things around, you're going to be using your application like somebody would be. And it tests the loop between the browser and the application. When you click, you're sending an event, and your application's handling that event and doing something with it. And we all know cross-browser bugs exist. Even if you implement directly the spec, there's going to be bugs, so we want to make sure that we catch those. We don't want your user to be the first one to catch that bug. And we test on many different browsers and platforms. My users aren't going to be just using Chrome. They definitely aren't going to be using JS DOM. And I want to make sure that it works in IE, it works in Firefox. I want to make sure it works in iOS and Android. All the things that my user is going to be using their application in. So what frameworks can do UI testing? You have the one that people mostly have heard of, right? Selenium. This has been around since like 2004. It's kind of the beast that everybody knows about. Then you have the new kid on the block, which is Cypress. It's really popular in the React community, and it's kind of taken off in other places too. That one's pretty new. And then you have Protractor, which is pretty popular from what I've seen with Angular apps. And then you have this interesting setup that people do with Jest and Puppeteer, which I kind of dig, because you get to use Jest, which is a pretty cool runner that doesn't run in the browser unless you hack it. But it only works with Chrome, right? So that can be a problem. But as a whole, UI testing hasn't really changed, or end-to-end testing or integration testing kind of hasn't changed, especially if like you're using something like Capybara or any other things. So this is what a Selenium test might look like. That could be pretty small if you're in the back. But you just know that like you're setting up a driver and you're driving the browser around. With Cypress, everything's done through the sci command, sci.get, sci.should, sci.do this. It's directing the browser. Protractor, which looks a little bit more modern, they have like a concept of page objects in there, so you can have an abstraction over the top of that, but you're still doing like browser.getTitle or browser.this, and you're driving it around. And then Jest and Puppeteer, which is a big snippet, and you won't be able to see it in the back, but on the test commands there on like line 13 and line 45, it has a 1.6 million millisecond timeout on that, which is like a half hour. It's pretty extreme. But it is an interesting setup, but it's still, again, a lot of driving and directing the browser to do things. Yeah.
Just sorry, really quick. I have a very minimal experience with Selenium, but they're basically like programmatically moving the mouse around and clicking stuff, essentially. All of these.
Right. Yeah. It's like it sits. There's a thing that's over here. You have like Selenium as a process, and then you have the browser as a process.
Sure.
And there's an interrupt in there, and it's kind of working between. So that's where you kind of can get those bugs where you're like waiting on an element, you're waiting for the browser to return to you, or you're putting sleeps in there to make sure that the element exists, so because you have these weird async problems. So UI testing hasn't really changed, but the way we build UI has changed in a really big way. We have to thank frameworks like this and like probably 100,000 other ones out there, because JavaScript, Backbone, React, Angular, Ember, Vue, all of these things have really changed the way we started building UI. We have a lot faster rendering. We're moving all of this logic into the front end rather than doing server-side rendering. Everything is now a component. It's componentized. We're breaking it down and being reusable and being able to compose things with them. Like I talked about, we have a lot more asynchrony going on. We have like a bunch of different HTTP requests going on, and things might return at different times and you don't know. They're more interactive because we're trying to be more like native, right? So we want to have that native like experience where it's slick and have animations and do things. So basically, building UI has gotten a lot more feature rich. We want to be like native apps. We want to be able to have that, but just in a different delivery method, right? Like native apps are really slick and fast, but you have to download that big payload to get to it. And then the web is on the other side of that, where you download a really small payload and you try to see if we can meet in the middle there. So we're trying to be as smooth as native apps can be, and native apps are trying to be as slim as web apps are being. So that change has caused a big boom in tooling. We have tools that have popped up all over the place like Babel, Webpack, TypeScript, ESLint, Parcel, Prettier, like all of these things that have helped build our front ends because they've gotten way more complex. But the UI testing tools haven't really evolved with the tooling world or with the front end world. And that's a pretty bold claim there. So what is missing then? What are we looking for when we want a UI testing library? Well, I want something that's built with components in mind. I want my UI testing framework to be able to just work with components and have that in mind when I'm building and writing my tests. I want composability in my tests that is similar to the way I compose my components when I'm building UI. I want reliable DOM interactions, so like when I click a button in a test and go assert against it, I want to make sure that that thing has happened. I want to be able to chain those interactions onto each other. So when I'm filling out a form, I want to be able to fill in this input, hit submit, and then assert something at the end and just do it in one thing. And of course, we all want speed. It has to be fast. It can't be slow. That's just a given, right? Everybody wants that. I wanted to take advantage of modern tooling. Things like, when I'm thinking of this, I'm thinking of like, it could be as simple as like using decorators in your test for using like test helpers, or stripping data attributes out of your UI, so when you ship it to production, you're not actually using those test attributes that you put there. So instead of using like classes, you don't have to tie your testing infrastructure to your styling infrastructure. I want maintainability and scalability. UI tests tend to become very fragile and get out of date fast. I've worked on 2 separate teams where we've had entire other separate teams that just maintain Selenium tests. And that was their entire job, to just write tests and maintain that suite. So we believe that the developers that are building the UI should also maintain the tests, and it should be simple enough for them to be able to do that. It shouldn't be a burden. They should just be able to do it as they go. We want full control over the network. I want to be able to create data as I need. This allows you to put your application in the weirdest states that you can possibly think of. Like if you need to test infinite scroll, you need to create 200 packages. You should be able to do that. Or if you need to test that infinite scroll's empty state, you should be able to create no data and then assert that that works also. So we're consultants, and we want to be able to take this thing anywhere, so it needs to be cross-framework. It has to work anywhere there's DOM or JavaScript. We want it to be cross-test framework also, because we're consultants, right? We're not going to be able to pick every technology that we go into. So we want it to be able to work in whatever they have: Mocha, Jasmine, Jest if you hack it to run in the browser, QUnit, any of the runners and frameworks out there. And this one is absolute non-negotiable. It has to be cross-browser. It has to be able to test in IE 11, Edge, Safari, Chrome, Firefox. And with how prominent mobile is, we really want to be able to test on mobile. I want to be able to make sure that these things work in iOS and Firefox on Android, and Chrome on Android, and just make sure that those things work. And none of the current frameworks really meet all of these criteria. A lot of them check some of the boxes. Cypress is pretty close, but only works in Chrome, and Firefox is kind of coming along soon, I think, last I checked. But they also don't take components into consideration either. So we went ahead and we built something. We built the thing that we kind of wanted. It's called Big Test because we're testing bigly, right? Unit tests are testing small, and your integration tests are testing big, right? You're testing the whole thing. So that's where the really creative name came from. It's a big test shield because tests should protect you. So Big Test is cross-browser. It works anywhere there's DOM and JavaScript. It uses a server to run the tests, so if you can visit a URL, you can run those tests, and that's what I'm going to try and get you guys to do in a little bit. It's cross-framework. It's plain JavaScript, so it will work with React, Vue, Ember, Angular, whatever you want, plain JavaScript. It'll work there. It's a cross-test framework, so bring your favorite runner or test framework. We tend to like Mocha, but you can use whatever you want. It gives you full control over the network, so you can create data as you wish. You can slow the network responses, so like if you have a really slow response, you can test that you have a loading state that works. You can throw 500 errors. You can do whatever you want because you have control over that network. And Big Test is built with components in mind. Components are kind of the center of Big Test. We ship these things called interactors with our component frameworks, and the consuming app can then import those interactors and use that directly to move their application around. And we'll get into interactors, and I'll explain those in a second. So I had a friend once tell me, if you're presenting a complicated problem, give a simple example. Do not give a complicated problem a complicated example because you lose everybody. So taking that to heart, we're going to do to-do MVC as a simple example. Everybody knows what to-do MVC is, or you can rep it pretty easily just from the presentation. So we're gonna big test to-do MVC, but we're gonna add an API to it so we can do some network mocking and stuff. So these are what the tests look like when they're running for a big test. So that's about 24 tests running in about 2 seconds there. And each one of those is re-rendering the application, tearing down the whole thing, and asserting everything. So what are our goals here for wrapping big test around this to-do MVC app? We want to be able to set up big tests in an existing project. We want to introduce and explain interactors. We want to build our component interactors. And we want to gain control over the entire network so we can mock it and put it in different places that we want. And we want to write some big tests and finish out the test suite. So the to-do MVC app, what does this thing look like? It's kind of your typical React app. So this is a React project. So you have your source folder with some components inside of it. And then for this example, we have some models that's managing the state. And then we have some API helpers. So it's a pretty typical React app. You use Parcel in this example to build, but you can use Webpack or whatever you want. And if you're not familiar with to-do MVC, this is kind of how the app works. You can create some to-dos. You can check them off. You can filter. You can wipe them out. That's kind of like the entire gist of to-do MVC. So it's not too complicated, right? So let's get big tests set up on it. What does it take to do that? This app has no tests, so let's wrap some things around it. We're going to install some dependencies. We're going to install the Big Test CLI. We're going to install Big Test interactors. We're going to install Big Test Mocha, which is our little wrapper around Mocha to write in a style that we like. You don't have to do that. You can use just plain Mocha if you wish. And then we're going to install the React helper to help you start rendering your React application as a full integration test. We're going to use npx here to run the init command. So what this is going to do, it's going to put some files into your project. It's going to create a big test folder in your root, and it's going to have 3 folders in there. It's going to have a helpers folder, which has a setup app, which that's the thing that actually renders your app into the DOM. Then interactors, which is how you kind of interact around and think about moving your app around. And then the test folder, which is how you actually write your tests, or where you actually put your tests that you wrote. Then you have 2 other things, which is the big test options file, which is where you put some options for the runner, and the index file, which is where we pull all of our files together. So the first thing that we need to do is tell Big Test Launcher how we serve our app. And with Parcel, this is pretty easy. We just need to change your bundler's entry point to the Big Test folder, so we're going to point it to the Big Test index file. So yeah, Parcel is really easy. We're going to create a big test index.html file because that's how Parcel kind of likes to work, is it likes to work off an HTML file. This is kind of just like the default way from Parcel's docs. And we're going to point it to the entry point to that file, which will then pull in all of our test files and everything. So we're going to go create a script in our package.json, and it's just going to be start:/test, which points to that index file. Will then package together all of our tests with our application together. If you're using Webpack, it's a little bit easier too, because the CLI and Big Test automatically sets the node env to test. So if you can just check if you're in test mode, if the env equals test, you can change your entry from your source index or wherever your entry usually is to over to the Big Test entry, and you don't even need an index file, index HTML file. So the next thing we need to do is we need to set up Big Test Run. And this is really, like if you install it globally, you don't even have to do this step, but I recommend not installing it globally. And set up so you have a script that looks into your local node module as a bin and calls that so you get the proper version that everybody else is using on your project. And then we need to edit the Big Test ops file. So we need to do 3 things here. The first thing is we need to tell Big Test how your application is served. And in our case, we created a new command, which is yarn start:/test. If you're using Webpack there, it would just be yarn start, so you wouldn't have to change anything. The next thing you need to do is tell Big Test where your applications actually get served to. So like if you're using, I actually can't remember what Create React app uses, but I think it's like localhost 3000 or 8080, I forget. But anyways, you just put wherever your application is served there. And for Parcel, it's localhost port 1234, which is kind of funny. And the last thing is you're going to tell it what test framework you're using. And in this case, we're telling it Mocha. We only have support for Mocha right now, but if you use any other test launcher like Karma or Testum, you won't do this step anyways. You'll just use Karma and how Karma does its thing. So let's take a look at some test files and actually look at what big tests look like. So this is our entire test suite right now. It's just one test that renders to make sure that the H1 says to-dos. And that's it. So that's what our tests look like. And then the interactor here, this is what an interactor looks like. We're going to, basically what this is doing is on line 5 is the key part here, is we have a property called title text, and it's going to grab the text from the H1 element on the page. And whenever you invoke that, so like back on this slide on line 15, when we do to-do app.titleText, that's going to return the text that's given from that element. And interactors make it so you don't have to worry about waiting for the element or putting any sleeps in there. It does it for you. It converges on the state of the DOM. So the last thing that we need to do is to set up is import our application's root component into the setup app helper. So this is what the setup app helper looks like. So we're using the setup app for testing helper from Big Test React. And this is typically what you pass to React DOM render for your application. So you're just going to pass that. That's actually what we're doing under the hood. But we do some other things that for you, like if you're using React Router, we hook into React Router for you so you can visit routes inside your tests and make it really easy. And then you also can pass like initial props here and whatever you might have to do to set up your application to render. So if we run the tests here, we're going to get one passing test. So hooray, we assert that the to-do H1 it's there. Yeah.
Sorry, I must be an idiot.
No.
Can you compare and contrast this a little bit to Selenium? Just because that's what I'm familiar with. What are you doing in Big Test that is a little bit different or an improvement over a driver-based approach? Or is it a driver-based approach?
It's not. We'll get to that because that's going to derail a little bit. So I'll try to, let's see if I can answer it. If not, I'll definitely come back to it. So we have successfully set up Big Test to render our application in the browser for us. And kind of the answer there is like there's no interloop there, right? With like Cypress or a Selenium thing, you're gonna you have Selenium standing over here, and then you have your app over here, and then it kind of drives it around and launches the browser itself. We're bundling your entire application together with your tests into one file, and then render that into the browser and drive it around. So there's no mix in between there. That's what makes it super fast, is we're just right there on the same browser process. So the next thing is let's pause and explain some interactors here. Interactors allows you to think about how you interact with your component or your application. So like click this, drag this, scroll here, focus this, get the text from this. They'll wait for elements to exist before interacting with them, so you don't have to worry about timing it perfectly and sync up with any run loops or anything. It just kind of does it for you. Interactors are core to Big Test. They're the heart and soul of it, and probably the coolest feature of Big Test. And you don't have to wait for the ability to interact. You don't have to worry about timing anything. It'll do it for you. Interactor properties are lazy, so they don't actually run until you call it, which makes it nice for performance. They're composable, they're chainable, and we think really powerful. And they can be used with any test framework on its lonesome. So if you don't want to use Big Test as a whole framework, you can just pull in interactors. So this is what we just did on an Ember project, because Ember has an entire integration test suite that is there for you. They use Testum and everything, and they take care of all that stuff for you. So we just use interactors. So if that's something that you would be interested in, go ahead for it. Big Test is just basically a collection of tiny packages like JavaScript is. So if you want to learn more about Big Test interactors, you can check out the guides and the API docs at bigtestjs.io/guides/interactors. There's like 4 guides in there that are kind of all about interactors and like how you compose them, creating custom ones, and all of the fun things that you can do with interactors. So we're a little bit more familiar with like what interactors are, but it's not really rooted yet. So let's just kind of start filling in our interactor, and it'll start to click together a little bit more. So interactors, like I said, we render your entire application with tests into the browser. In other frameworks, you're usually like the Selenium or Cypress will tell the browser to do this and then drive it around. Interactors are actually the thing that's driving your application around. So your interactors will click the thing and go to a new page or drag this thing around, and then your test framework with interactors will assert that that page state exists. So in order to build our interactor, we kind of have to think about how we even interact with our app. And for a to-do app that's supposed to be simple, there's a lot of little different things that you can do here. You have the H1 that's at the top that we can assert on. You have a toggle all button that's right in your new to-do input. You can complete a to-do. You can double-click to edit an item. You can delete that item. You can do some filters on the bottom. You can clear all the ones. So there's a lot of things that you can do there. So let's break this down and just tackle just writing a test for adding a to-do. So the same diagram, but pull away a lot of the stuff. We're actually already a little bit further there, right? We're already asserting that the H1 is there. So now we need to be able to fill in the to-do input and press enter to submit the to-do. There's no submit button, right? So there's also a button to the left there that you can use to toggle all the to-dos. So let's create an interactor. And specifically to creating a new to-do, I want to call out line 12. We have a new to-do property on the interactor, and it's equal to a fillable property, which allows us to fill in inputs. So we're going to pass the class name of that input to it. And the next thing we're going to do is we're going to create a submit to do property equal to a triggerable method that interactor also provides. And this allows us to trigger all kinds of events. You can trigger custom events, whatever you want. In our case, we're going to trigger the key down event and pass the key code 13, which is enter, to the new to do input. So that's cool, but how do we use it? So from the top, we have we import our interactor from the interactors folder, and at the very top of our test file, we instantiate that and create that interactor, and we set it to a variable called to do app. And then down there in the test center before each, we do to do app.new to do, and then we pass the string that we want to be filled into that input. And then chain right on that the submit to do interactor that we created that will actually hit enter for us and create it. So if we look at the interactor, we have the new to do property that's there, and then the submit to do. New to do takes arguments because you're going to fill in an input. So that's awesome. So we did some things, but how do we assert on that? If you look down on line 26, it's just a comment that says, uh-oh. So how do we actually assert? And that takes us to the next part. In order for us to assert that we've actually successfully created this to-do item, we need to think about each individual to-do item that's there. And when we were building this UI, there's already a to-do item component. When we recognized when we were building this UI that we could pull that repetition out into a component. So that's to-do item. So naturally, let's create a to-do item interactor so we can match that same composability that we have with our components. So we're going to create an entirely new interactor called to-do item. And for this, we're just going to have one property right now called to-do text, which grabs the text of the label on that item. And it's a very, very broad element that we're selecting here, right? To do, or just label, which I'll show how we do that because you could select like 15 labels, right? So how do we do that properly? But we can compose our to-do item interactor with the to-do MVC app interactor that we have. So that's exactly what we're going to do. On line 16 here, we have a new property called to-do list, and we're going to set equal to a collection, and that collection is the to-do list div of list items. And then we pass that to-do item interactor that we just created that is imported on line 9. And we're able to select the label as generic as possible because the collection scopes all of your interactions inside that nested interactor to that element that your collection is. So now we can assert that that new to-do item is created. So that's exactly what we're going to do. On lines 23 to 25 here, we're going to do to-do list or to-do app.to-do list, and then the first index there, which is 0 because it's 0-based, dot to-do text. So that's going to pull the to-do text off of that, and then we're going to assert that that equals my to-do because that's what we're creating there on line 20. So let's run the tests. Yay! We have one to-do item. Or we've created a to-do and successfully passing everything. So let's fill in the rest of our to-do item interactor, because you can do a lot more different things with a to-do item. You can click the checkbox to toggle. So line 13 there, we have a property called toggle, which clicks that button for you. If you want to delete, we click the delete or the destroy button. We can check is completed because they're checkboxes, right? So we can grab the property checked off of that element to check if it's checked or not. We're going to trigger to edit. To be able to edit those items, you double click inside of them. So if we want to edit, we're going to trigger a double click on that label. And then when you're in that edit state, we can then fill in the edit input and we can press enter to submit that edit. So that's a fully filled out to-do item interactor there. So that's a lot being thrown at you. So let's take a second to pause and check our progress. Interactors are maybe catching a little bit more on. So let's write more tests for editing, deleting, completing a to-do. And there's a problem here though. At the beginning I was talking about end-to-end tests versus UI tests. These are all end-to-end tests still. We're still talking directly to the API. And technically for this app, it's production API. So we're creating production data for each test run that we have. So right now, for each test run, I'm refreshing each test here and we're creating a new to-do and it's creating 6, 7 to-dos each time I refresh because it's committed and persisted to the API. So we're going to use a package called Big Test Mirage. Mirage creates a client-side server that mimics your API. It has a fully featured database ORM. And this allows you to have full control over the data in your tests. Like I said, if you need to test pagination, you can create 200 records if you need it. You need to test the empty state, you can do that. If you need to throw a 500 error when you're submitting a form to make sure that your client-side errors work, you can do that. You can have full control over the network to do whatever you want to put it in the weirdest state that your users usually find themselves in. So I want to give a shout out to Sam Selikoff for this. If you use Ember or are familiar with Ember, this might be really familiar because it's pulled right out of Ember CLI Mirage, and Sam Selikoff built that. So we pulled that into a base JavaScript library so everybody in the JavaScript community could benefit from this awesome thing that he built. So thank you, Sam. So we're going to go back to the big test init command and we're going to run it with a network flag, and that's going to put in a network folder into our app, and it's going to do some of the bootstrapping that we need to do. And then we're going to add that dependency as a dev dependency. And we run that init command, it creates this network folder, which has a lot of subfolders in there. We'll get a little bit more familiar with them, but just know they kind of exist for now. And the next thing that it does is it updates your setup app helper for you. So the changes to it is it's going to import a setup or a start Mirage command, which starts that client-side server for you. And then it adds 2 methods here that the setup app for testing helper gives you, which allows you to do whatever you need before the app is actually rendered, and then do anything you need to do after the app is rendered. So you have setup and teardown methods there. So in the setup, we're going to start the Mirage server. So this creates that client-side server, and we'll start intercepting HTTP requests for you. And then afterwards, we want to clean up after ourselves and make sure that we shut that server down because we don't want it to linger. So what happens if we ran our tests now? They're very broken. Why is that? So if we look in our console here, we have a lot of errors. And it's because Mirage is intercepting each request that happens. And if it's not mocked for you, or if you're not intercepting those requests and handling them, it's going to throw an error and say, hey, you need to do something with this. So this is what it looks like. So Mirage intercepts all of those things for you. You can have them pass through to the real network if you want, but you have to explicitly say what you want to do with that request. So in this example, it's catching a post request. So it's like, hey, you tried to post to something, but you don't have anything to handle it. So let's do the first thing and mock our get endpoint. And if we go to our big test network config file, this is what the config looks like. And on the first or the second line here, we have a thing we're setting a URL prefix, and we're going to set it to the fully qualified URL of our API. So in this example, we have a big test to-do.api.herokuapp/todos. That's where our API lives. So this allows us to do on line 4. We don't have to pass that fully qualified URL each single time. We can just pass the root because that's where we're going to be hitting here. So when you do a get on the root of this, we're going to return just fixture data. It's going to be a array of a single object, and it's going to be the same thing each time. So if we run the test now, a little bit less errors in the console, and we finally have an app that renders something. But then it fails again because we try to submit a to-do, and that's a post request. So let's mock the post endpoint there. And it's going to be the same exact thing for the post, except it's going to be this.post instead of this.get. And we're going to return the same exact fixture data. So these tests pass, right? Then in this configuration, they'll always pass because we're sending and asserting the same exact data and the same exact shape. So they pass, right? But fixtures are not going to get us very far. Fixtures are static, and once we need to test something that's different from the fixture that you have set up, it gets really complicated and you're going to have a really bad time. So let's use dynamic factories for this. This will allow us to create that specific data that we need and have full control over that data. So we need to create a model and a factory. And in the near future, the CLI will take care of this for you, but it's a little bit harder to like, you know, pull everything up into an AST, parse the file that you have there, and then put in the things that we need to do so we don't clobber your code there. So we're going to do this by hand for now, probably for the next 6 weeks. We're working on it. But we're going to import, or we're going to create we're going to export a to-do model from the to-do file that we're going to create. And that looks like this. And this is a place where you can create relationships for all those models or has-manys or whatever you need to do that your server does for its models. We're not doing anything special with it, so we're just going to extend the base model and send it along. We're going to create a factory for the index and export that. Then we're going to create a factory file, which is to do. And we're going to create a factory that has the fields that our API and our model expects. So in this case, we have a completed, a title, and an underscore ID, which our API passes along because it's a MongoDB. So I want to point out here on line 5, we're using Faker to generate fake sentences for each title. So each time you create a new factory, it's going to create new fake data for you. And then when you actually create this and create this data in your test, you can override these things. So if you want, you could just pass your own title and it won't use the Faker data. So this allows you to create a title that you can then assert against that is known, right? It won't give you something random each time. So we have to then uncomment those imports in the network start folder. So this is some of that manual work that I was talking about that we'll get to, but for now we're playing it safe and we don't want to clobber any code that you might have already set up. So we're just going to uncomment the factory and the models import and get going. So now we can create that dynamic data that we want. So we'll go back to our route handler for our API there, and instead of just returning that fixture data, we're going to destructure. So the first argument that's giving in that route and that function is the database schema. So we're going to destructure the to-do out of that database schema, and we're just going to return all the to-dos. And then for the post, what we're going to do is we're going to destructure that to-do model from the database schema, and then we're going to take the request that comes along with it, and we're going to parse that request body. We're going to create a new to-do from those attributes that are in the request body, and then do a little bit of things for our API to add that underscore ID there. And then we're going to return that newly created to-do, and that adds it to our database schema. So Mirage has a concept of scenarios where you can create, a scenario from anything. So we're going to create a scenario, and this file is there for you, so you don't have to create it. And by default, we're going to create 4 to-dos. And just be sure whenever you put something in your default scenario that is really what you want to do, because this will be created each time your test runs. So if you have a scenario where you want to test no to-dos, don't do this. So let's run the tests. But they fail. So what's up there? So if we take a look there, our API that we have, our mocked API, is returning a payload with a root key to-dos on there, and what our app is actually expecting is just an array of objects. So we need to serialize the data to match the shape that our API has, so we're going to create a serializer and then serialize that data for us. So Mirage out of the box comes with 3 serializers. You have a REST serializer, you have an active model serializer, and a JSON API serializer. And then you can implement one by your hand if you want, but we're just going to use the basic REST adapter and do some serialization and send it along. So now if we run our tests, they pass. And now we have some fake data in there. We have 4 to-dos in there that have some lorem ipsum, and we have that one to-do that we just created in that test. So we now have mocked the entire network and we have control over it, so we can do whatever we want. We can fill in the rest of our tests, things like editing and toggling and deleting to-dos and all those things. So nested interactors are pretty sweet. So on line 4 here, we have a to-do app dot to-do list, and we're going to double click in it, and then we're going to fill in that to-do item, and then we're going to press enter to submit that edit. But when you have nested interactors, you don't want to have to type to-do list index 0 each time. So you can have a little trick here by just passing chaining a dot only on there, and then your subsequent commands there will only be on that nested interactor. So you don't have to type that out each time. So it's just a little tip there to make sure that you don't have to type that out. So for our network mocking, when we do an edit to a item, it's a patch request, and we're going to do a slash on the ID. So we're going to do the same thing we kind of did there, is we're going to pull those to-dos out of the schema. We're going to find that in our to-do schema from the request ID that's passing the params, and then we're going to update the attributes with the attributes that are in the request, and then update it and send it along. And then for the delete, that's pretty easy. We're just going to find that ID for that to-do and just destroy it and remove it from the database. So if you saw earlier, if we run our tests, we have 24 tests that run, and they run about 2.5 seconds, and we fill them all in. So we're actually editing, deleting, filtering, doing all the things that you can. We exercise the entire to-do MVC app there. So just so you know that I'm not lying, this is me running the tests in iOS Simulator, Firefox, and then Chrome. So they all work there. So this is the part where I have not tried this, so I don't know how it's going to go. If you go to that address with the port number 4567, hopefully you can run some tests and see them run actually on your computer. And then, oh no, actually I need to keep that up. So then,
I have one final stupid question.
there's no stupid questions.
I will challenge you on that. So there is a lot of material to cover, and I apologize I didn't sleep
It's a
all
whole
last
lot.
night, and I think I may have passed out for part of it, but it was very interesting. Do you happen to have your trivial example on GitHub somewhere?
Absolutely. That's a little bit further in the talk. I'm not quite done,
Okay, cool.
but I just wanted to see if people actually could connect and run these tests.
Let me see.
I want to see. Let's see. It may work. I don't know.
Oh, no, you took the thing out.
Yeah, I'm trying to. Let's see. Where is it?
What, that,
There we go. So I want to see if anybody's actually running the test, because it'll show them. No.
4, 5, 6, 7.
Let's see. There we go. Somebody connected.
Yeah, they all run.
So we have a dot reporter. That's what's happening there. So each dot that happens, somebody's running a test, which is kind of cool. So that's. I'm happy that actually.
Is there something supposed to pop up, or is it just supposed to dot you?
So in the CLI, it'll just have dots, because that's the dot reporter that we have. You can have a different reporter if you
Because my
want.
page isn't loading anything.
Ah, so that might not be working.
This is my,
There might be something. If you check the console, there might be something funny going on.
ooh, interesting.
But we got some failed tests in there too. So that's interesting. I want to know if anybody's browser has bugs. Let's see, what were the Safari 12? What was it? Oh, focus. So if you mess with the tests while they're running, it'll alter the outcome. So I'm assuming somebody might have tapped and then moved the focus out. So that's what happened.
Do you use any particular ports when you run this?
No, kind of just picked random ones, like 4, 5, 6, 7.
I mean, other than this one, because I've got other.
I think it's 5, 6, 7, 8 is where the proxy server runs. So there's some trickery going on in there where we inject some big test stuff.
This might be shadowing my own ports.
Gotcha.
Oops.
That might happen. Okay. Let's see if I can. Hey, we got more tests running. Can I drag that back over? Come back. So that worked. That was nice. So cool. So this test suite is ported exactly over from the test suite that Cypress has. So I gave this talk at JSConf, and funny enough, the person that gave the talk right before me in my slot was the Cypress senior engineer, and they also gave a talk that was centered around testing to do MVC. So I immediately grabbed that night that test suite and ported it over to see how we stacked up. And this is Cypress running the same test suite. It takes 30 seconds to run. So I'm not even gonna wait. You can find the full test suite if you want to check it out at github.com/robdel12/bigtest2do-MVC. I've given my slides, so you're able to check them out. Also post them on the meetup page, so you can get that link. So we've successfully did it, right? We set up Big Test in an existing project. We got introduced to interactors and got our feet wet a little bit with them. We built some interactors and we controlled the network and we wrote some big tests. So coming back to this complicated problem, we want simple examples, but I want to give a little bit more complicated examples just to show that you can what we do. So we have a client that is 100% open source application, which I'll link to later in some slides. This is one of the tests that we have. And I wanted to show this one because we actually have some data that we're creating here. So it's a data called resource. So we're doing this.server.create a resource, and we're passing some attributes in there that we specifically want to test for. So what we're testing here is we want to test that when we create this thing and we set the package to be hidden, we want to make sure that in the UI that you can actually do some things with it. So we create that data, and we also reference some relationships here. So like on line 6 here, we have a package, and we have already created another piece of data called package and set that to a variable. So we just pass that in to use that one. And then after we create that data, we visit that route with the ID of that resource that we just created. And then we do some assertions to make sure that it works. So a little bit more complicated example, another one would be filling out a form. So this one, we're filling out a form to be invalid. So we're gonna fill in, there's some date pickers here with a bunch of, like you can add multiple date ranges in this example. So we're gonna pick the first date row, and then we're going to fill in some dates. We're gonna put in a bunch of text into a text area. We're gonna click a button. We're gonna put an empty value in there, and then we're gonna submit the whole thing. And then we're gonna later assert that these things have errors on the page. So this is what the tests look like when they run, right? And this is building the application and tearing it down for each assertion. And if you quickly can see in there, you can see some errors that are happening on the inputs as the tests run. So that a little bit more complicated. And then one of my favorite examples is we did a lot of work to make sure that this single page app has accessible routing. So anybody that's using Assistive Tech or screen readers or switches or anything can navigate this app. So that was a lot of work, and it usually goes unnoticed if it's broken, but we actually wrote tests to make sure that the focus management works. So in this example, this app has a 3-pane layout. In the middle is an infinite scrolling list, and if you select a package and then it opens up that third pane on the right, it should set focus into that pane and focus the title. So we're going to assert that the focus is on the title, and when we close that pane, we want to make sure that the focus is set back onto that item that you selected in the list, because it's an infinite scrolling list, and you should be able to go back to where you were coming from. So we wrote tests to make sure that that doesn't break. So that's what these tests are. We're actually asserting, we're rendering the application, doing a search, and opening the pane, and then making sure when we close the pane, the focus is set back in the proper spot. So this application is all written with Big Test. Has over, at the time I wrote this talk, it was 1,000 tests. I think it's up to 1,200 tests now. It takes about 6 minutes to run the entire test suite, all 1,000 tests, building the UI, tearing it down. And we have about 96% test coverage on that. So it's all open source. So if you want to check it out and see what a full suite looks like for Big Test, it's at that URL. So I want to wrap up, I want to cover some things that people usually ask me about. What about GraphQL? GraphQL is actually a lot easier to mock your API with. You just basically get to skip that entire step with Mirage. Since GraphQL has type defs and definitions, you can just pass your schema, and it can just mock it for you. So I think Apollo provides some mocking helpers for you. So you just have to use that, and it does it for you. So it's really easy. You don't have to do any API endpoint mocking or anything. You just pass the schema. What about testing just components? Because interactors are kind of cool, and it makes sense to test just components, and that's exactly what we do. I kind of talked about it at the beginning. So in this eHoldings, the application I showed you that's fully open source, we have a component library called Stripes Components, and we test those components just individually. So we have a mount helper from Big Test React, so it allows you to mount a component into the browser. And in this test, so we have interactors with it. In this test, we're asserting that when we pass a prop called warning, that in the browser it has some feedback text that says, hey, that's not a great value, which is what we pass as a prop that we're making sure. And in an interactor for that checkbox, it uses CSS modules. So you just import the CSS module and then use those as selectors. So you don't have to worry about how it's going to work with these dynamic objects or the dynamic class name that it gives you, because usually it just comes off an object. So you just pick it off and pass it to the interactor, and you're good to go. So in that specific example, on line 13 here, we're doing checkbox.feedback text equals what we passed to as a prop. And on line 22 in the interactor, the feedback text is grabbing the text out of the page from the CSS module that we have. So you can get started by visiting bigtestjs.io. We're working on a getting started guide. This talk is kind of like the getting started guide for now, because we're kind of starting to write those things right now. I also gave this talk at JSConf and an online conf called ByteConf, so I can link on the meetup to the ByteConf talk because it was recorded and was online, so you can go as you're at your pace, because I know I covered a whole lot of information really fast, so you can visit that. Big Test is still in its early days. It's really just starting off life. We started this like 6 months ago, and turns out building a test framework is a big task. So in our fully fleshed out here emoji map for our roadmap, we have the CLI, we have the network things, and the runner. So the first thing is we want to finish out the CLI. We really want to do zero config in mind. We want to make sure that you're focused on writing tests and not mundane things like boilerplate code or doing anything like that. We just want to make sure that it handles that for you. The CLI also handles launching, which is what we use in this test. But if you don't like that, you can bring your own launcher. You can use Karma, or you can use Testum. So you can use whatever you want as you go through this. The network, so we talked a lot about Big Test Mirage, but we actually want to replace Big Test Mirage with something that uses service workers to intercept network requests. Because right now what Mirage does is it overrides the XML HTTP request in the browser and then intercepts the requests. So you lose your network pane when you're debugging, because you have a full browser there. So whenever you have a thing that happens in a test, you can just open up DevTools, throw a debugger in there, and go to town. But that does mean that you lose your network pane because of the way Mirage intercepts those network requests. So we want to eventually write something that uses service workers, and we can do some other cool things with service workers, like mock network requests as they fly by for you if you want. But you know, Mirage works. It's a fully featured thing that we haven't written, so we're kind of putting that a little bit later. And then the last thing, and maybe like mid to late 2019, we want to write our own runner. We could actually make, so that eHoldings test suite takes about 6 minutes. We can probably cut that down to about 2 minutes, because when we write our own runner in the style that we wrote those specifically, we're able to break up the before eaches and the nested describes and run all of those in parallel. So we want to be able to do that, but that's like, we don't want to write a runner right now. Like, just use Mocha or Jasmine or whatever you want. But that's planned in the future. We're also planning other things like, you know, what Cypress has, like record a video on fail or a screenshot, or dynamic network mocking. Those are all things that we can do, we can definitely do, but right now it's literally one person writing this, and that is Will Wilsman. He's not here, but I want to give a big thanks to him, because he basically have written all of this himself. I've contributed a little bit of code, but most of my time has been talking about it and trying to get other people to notice it. And I also would like to give a big thanks to Frontside for sponsoring all the work, because you know, it takes time to do that stuff. So yeah, thanks. Any questions? Hey,
Any questions for Rob?
I'm sure there's.
Yes. Obviously, it's very cool. Can you talk a little bit about the plumbing that goes on underneath between the actors and the actual app? You know, how do they actually interact with each other?
So interactors really are, if you look at them, they're just kind of like plain JavaScript that are creating and like doing actions for you. So like on an HTML element, you can do .click, and it'll actually send that like click event. So that's kind of what we're doing under the hood. So like we'll set an input property to the value that you pass, or we'll trigger an event. So it's happening right there in the browser. There's like no interop or anything that's happening. So an interactor really is just like, it's an abstraction over where we came from like 2 years ago, where we were just using straight jQuery. So it's kind of like a page object that is more composable and encapsulated to a component, is kind of where interactors come from. So like we were using jQuery when we were just doing like .click or .value and like sending a value to it or whatever. So we've kind of abstracted over the top of that and created interactors. And they're all based JavaScript, so there's no jQuery dependence or anything.
Okay. So
Is that-
it's running on the same page as the app,
Yeah,
so it is able to control it.
exactly, yeah. So like interactors drive the page around, and then the test suite will assert against that.
That makes sense. So is this only used for spa type of application, or can it be used for, traditional web app that you serve from the server side?
So it's possible, but we would have to sit down and pair on it because we haven't done that. So like Big Test, it bundles all of your test and application code together. So that's why we like changed the entry point of like Webpack or Parcel. It's possible to do that. So like we've kicked around the idea. We have one of our sites are Middleman, and we want to be able to use Big Test to test with it. But we would have to basically figure out how it bundles the code together and make sure that the code that the tests are written in also gets bundled with it and drives it and does those things. So out of the box, it can't do it, but it is definitely plausible. We'll get there. We'll get there because we want to use it too.
Cool, thanks.
Awesome. Any other questions?
So the performance gain that you have over like Cypress is pretty drastic. I'm wondering if you have any insight as to why that is. Like, are there big reasons, ways that you guys are writing the code that makes it so much faster?
Yeah. So like Cypress has it has its own process that's alongside of it, and they're like driving the browser, and so they have to wait for the browser to come back. We're like right inside the browser with like the same browser, and we use a thing called convergence. It's not like it's not a original idea, but basically we converge. The name came from we're converging on the state of the DOM. So it's basically just a 10 millisecond timeout that runs for 2 seconds. And if it doesn't achieve the thing that you need to do, that you were trying to do, it'll fail in 2 seconds. But the idea there is asynchrony, right? So anytime in those 2 seconds, that action could actually happen. So like if you're looking for a button and the button doesn't exist on the page yet, it's gonna check every 10 milliseconds until it does, and then it's gonna do the interaction. I don't know how exactly Cypress does it under the hood, but as soon as it's available for us, we do the thing that we can do with it. So that's kind of where it happens, because like when you're testing things, like you have your cause and effect, and flaky tests come from when you have like you do the cause, right? You click, and then the assertion happens. But what if your assertion happens here and the effect happened right after it? And the test run before, the effect happened right there. With convergences, it doesn't matter because we're just checking every 10 milliseconds until it's there. So it's like, it felt a little hacky because it was just a timeout I was checking, but it's actually super robust. And we're just kind of like built a pyramid right on top of that. So like interactors are built heavily with convergences, and the CLI actually uses convergences to make sure that the browsers are all connected and everything. So that's kind of how we're able to do that, because we're just right there on the same process. And then Mocha will report back to the CLI for us.
Okay.
So yeah, it's just like in the same browser, the same right where your app is. So basically, Big Test can test your application as fast as it can render, and can do the things. So if your big tests are slow, your app might be slow. Maybe. Does that answer your question?
Yeah.
Okay, cool.
Thank you.
No problem. Any other questions?
One more question. in, Selenium, you can use Gherkin type of language to write tests, which is a lot more intuitive as opposed to writing code. Do you
Mhm.
guys have any plan like that?
It's not on our official roadmap. We've definitely kicked around the idea of using Cucumber, but we definitely think like the people that are building the applications should be writing the code along with it, because they know the intimate details and they're maintaining the code. So we haven't looked at that. We've like kind of thought about it because there's definitely a Cypress plugin out there that allows you to write Cucumber style tests with Mocha. So I'm sure it's possible, like especially if you use Mocha, but I haven't really looked into it to see like the amount of work that it'll take. So the answer would be no, to give a short answer.
Thanks.
So if anyone else has any questions, we can hang around for a few minutes and you guys can ask, but
Yeah.
we can wrap that up. So thanks, Robert. That was great.
Awesome, no problem.
Real quickly, I do kind of feel like you guys got shortchanged earlier because that GitHub link came back up. So just before I do this, just last announcements, reminder again, if you did park here, please get a parking validation. Also, we have 30 minutes to hang out here if anyone wants to just hang out, and then if anyone's interested, we could go downstairs afterwards. It's up to you guys. There's still beer and stuff back here, so feel free to hang out for a little bit. And then, yeah, this is Donkey. So this is it. So this is running in the browser, and this is the entire game. So if you run into the donkey, you explode. The cool thing about this, actually, so this, when you look at the DOM, all you see is well, let's see, let's bump that up a little bit. If you can see that, all you have there is a canvas tag. Everything's done kind of dynamically. If you go to the sources tab, can't make this much bigger.
I'm surprised they didn't just go like, let's Spasm.
So the only two things that are loaded on the page are the Web Basic library itself, which is JavaScript as you would expect. This is essentially the basic interpreter written in JavaScript. And what it's doing is it's interpreting basic code and translating it into like Canvas output. So it's like literally plotting basic style graphics on Canvas, which is kind of interesting. And then when you look at the HTML file, all it's doing is it's loading the basic interpreter JS file, and then it's loading this raw donkey.bas file. And if you look at that file, this is it. So it's literally running this code. It's importing this code directly into the browser, and this code is being interpreted by that JavaScript and spit out as what you saw there as that game. So if you've ever written BASIC, you might have some nostalgia for this. If you have never written BASIC, congratulations. It's not that fun. I actually have written BASIC long, long ago. But anyway, so I thought that was kind of fun. So thanks again, appreciate it. Feel free to hang out for a minute. Please eat some more pizza before you leave because we have a little leftover, and come back next time. Thanks.
Good talk. Sorry for all my crazy questions. I'm operating for some reason I get like 0. So I'm half a breakfast coffee and that's about it. So
That's
not even a full? Yeah, right.
no, those were great questions.
Yeah, no, you were just going a little fast for me.
Like I did this talk.
I could tell it was for like people really. Yeah, like a flag. This is what they do. And
Yeah.
according to here, and we're like, yeah, really good stuff.
It was, and even then, like, I was trying to keep it in a reasonable time because it was written for an hour. So I was like, I cut some stuff and then like tried to just not super long. But yeah, no, any questions are great.
It is interesting. You want to know something funny? One of my projects for Selenium, what I did is I found out that Selenium to apply for jobs on Angel List.
That is amazing.
And I pushed
You
the
can
button,
automate it?
there's like 1,000 jobs.
I'd like to take a walk on that.
That's pretty slick.
Yeah, it was pretty fun. And actually,
man, I,
asking you, they start asking you like, how do you write School List? And then you feel
yeah, so,
we're not really talking about really how you feel about Angel List.
I had a friend that wrote
the initial ones that I
automated thing. So he's really into sneakers, and he
I just found out like a couple
like
hours ago.
So when Yeezys come out, he'll basically spin up this like server farm with 1,000 bots using Puppeteer and check out the process of buying shoes.
So you can like get around like the wait list and stuff.
Exactly.
Oh, hey, how's it going, man?
So it's funny because it got caught with CAPTCHA, but those sites use the Google CAPTCHA. So what you have to do is you log into your Google account, click the button, with Puppeteer or real events. So it's just you can just
I get
CAPTCHA, which is pretty slick.
anywhere from 10 to 100. So yeah, I mean, by all means, if there are people that like sometimes there are apps with direct clients and sometimes referring people to someone else. But yeah, by all means, I'd love to. The more the merrier. So. Is it like got a lot of roles or I get all kinds of stuff. So no, like a lot of people reach out to me for or for you, but also a lot of data. So sometimes general analytics, data science, which is
No problem.
I still kind of work, but you know, so like those kinds of things. Every once in a while, this doesn't happen as often, but there will be events or like
And that's how we,
some groups are hiring.
zero testing, and now there's a little bit of GS testing.
It's like it's usually clients that don't
Newer
quite
stuff, I think,
understand
was
what their things are, and so they're looking for that person that can kind of guide them from being yourself locked in.
A real node.
Yeah,
So for us to drive our development, every so often we hook up to the real server. In our environment,
Well, yeah.
the real server is
I run into Slack channels often.
there's a gateway that talks to
Yeah, by all means, yeah.
setting that whole thing up with all the simulation.
Yeah, take it down. Yeah, man, I can actually.
Sounds like just like my we had almost exactly all of that. Is it a corporate environment? That sounds.
It's actually.
Okay.
So, I'm new to all this stuff, you know, with Webpack, you get the dev suite. So you can proxy auction configuration, so, all of the mock stuff we use just to do our manual development is accessible from a chess. So I've been playing around with this, so I can open up Node and pass it the same config that we use in our mock. And so we've got this one test that, so our app comes out with such a data, it just keeps on computing. So it wasn't testing UI, it was just testing that all the state got it. But
A true unit.
yes, yeah, but it's but kind of a full system testing, and you're not having to mock the all that knowledge, you get the real thing.
Gotcha. Okay.
But I know that this probably really isn't a good idea. Everybody thinks it, everybody really normally is racist, I know you should.
I'll see if I can.
I'm a little stubborn.